In the grand, silent theatre of the cosmos, we have long cast the planets as the lead actors. We see the furious, marbled beauty of Jupiter. We witness the serene, stately grace of Saturn and its iconic rings. We are captivated by the fiery drama of Mars. These are the Titans, the celestial protagonists of our solar system's story. But this is a misreading of the script. The most profound, the most tantalizing, and perhaps the most important tales are not being told on these grand stages. They are whispered in the shadows, in the orbits of these giants. The real secrets are kept by their attendants, their companions, their moons. For decades we saw them as little more than barren pockmarked stones, loyal but uninteresting servants to their planetary masters. We were profoundly, wonderfully mistaken. These are not just satellites. They are worlds in their own right. They are dynamic, enigmatic realms of staggering complexity. Some are covered in ice that conceals secrets on a global scale. Others possess atmospheres thicker than our own. A few erupt with a strange frigid volcanism that defies our terrestrial intuition. And the most tantalizing possibility of all, the one that fuels our most audacious dreams, is that beneath their alien surfaces, in dark and hidden places, something might be stirring. The story of life in the universe may not begin with a star, but with a moon. Join us on a journey to the farthest and most mysterious of these celestial bodies. We will travel across billions of kilometers of vacuum, to worlds that challenge our definitions of what a world can be, and ask the ultimate question, are we alone? This is a voyage to the solar system's hidden jewels. Our first destination lies in the court of the king, Jupiter, a colossal ball of gas so immense that all other planets could fit inside it, governs its own miniature solar system of nearly 100 moons. 4 of them are large enough to be seen from Earth with a simple telescope. It was in the year 1610 that Galileo Galilei first pointed his crude spyglass toward the heavens. He was not just looking at stars, he was looking for a new reality. Night after night he watched 4 tiny points of light dance around the great planet, shifting their positions in a constant, predictable ballet. He called them the Medicean stars, but history would know them as the Galilean moons. This discovery was more than just an addition to the celestial catalogue. It was a cataclysm for human thought. For the first time, we had incontrovertible proof that not everything in the universe revolved around the Earth. This simple observation shattered a thousands-year-old worldview. For centuries, these 4 attendants remained little more than faint sparks. Io, the volcanic inferno, Ganymede, the largest moon in the solar system, Callisto, the ancient cratered elder, and then there was Europa. Even from a distance, Europa seemed different. It was brighter, smoother, reflecting more sunlight than its siblings. It appeared an almost perfect placid sphere of white. It wasn't until humanity sent its robotic emissaries, the Voyager probes, on their grand tour in the late 1970s that we began to understand why. The first close-up images were baffling. Where there should have been a landscape of craters, the pockmarks of cosmic history, there was something else entirely. Europa's surface was a vast, fractured canvas, crisscrossed by an intricate network of reddish-brown lines and ridges. It looked less like a moon, and more like a shattered porcelain egg, intricately glued back together. It was a world that seemed to have wiped its own history clean. Something had erased the billions of years of impact. The surface we were seeing was young, geologically infantile. The lines, some stretching for thousands of kilometers, looked like immense cracks in a shell of ice. The implication was as clear as it was revolutionary. Europa was not a solid, frozen ball of rock and ice. Deep within this moon, something was generating enormous energy. The source of this power is not the sun. At this distance, our star is a feeble thing, its warmth a distant memory. The engine that drives Europa is Jupiter itself. Imagine holding a small metal paperclip between your fingers. If you bend it back and forth, again and again, you will feel it begin to warm up. This is a simple demonstration of friction and deformation generating heat. Now, amplify that principle on a cosmic scale. Europa is caught in a relentless gravitational tug of war. Its orbit is not perfectly circular, it is slightly elliptical, pulled and pushed by the gravity of its neighbouring moons, and Ganymede. As Europa moves along this path, Jupiter's colossal gravitational field stretches and squeezes it. The Moon's very shape is deformed with every single orbit. This constant rhythmic flexing is called tidal heating. The interior of Europa is being kneaded like dough, generating immense frictional heat deep within its core, and this heat has a profound consequence. It is powerful enough to melt the ice from below. The fractured, youthful surface we observe is not the world itself, but merely the frozen roof of a far greater hidden feature. Beneath this shell of ice, which may be several kilometers thick, scientists are now convinced there lies a colossal globe-spanning ocean of liquid saltwater. Let that idea settle. An ocean, larger in volume than all of Earth's oceans combined, sloshing in the eternal darkness, 1 billion kilometers from home. This is not science fiction. The evidence is compelling. When NASA's Galileo spacecraft flew past Europa in the 1990s, its magnetometer detected a strange disturbance in Jupiter's magnetic field. The readings could only be explained if Europa contained a layer of highly conductive material, and the best candidate for such a material is a salty liquid ocean. The surface itself tells the story of this hidden sea. Vast regions known as chaos terrain look like cosmic icebergs. It appears as though huge chunks of the surface ice have broken apart, drifted, rotated, and then frozen back into place, like ice flows on a polar sea here on Earth. This suggests that the ice shell is not static. It is a dynamic crust, floating atop a liquid interior that occasionally melts it from below. In recent years, the Hubble Space Telescope has added another electrifying piece to the puzzle. It has captured faint but tantalizing evidence of vast plumes of water vapor erupting from Europa's surface, shooting hundreds of kilometers into space. If confirmed, this means the ocean is not a sealed system. It is actively breaching its own icy prison, venting its contents into the void. And so we are drawn to the ultimate inquiry. If there is liquid water, and if there is a source of energy, could there also be life? On Earth, wherever we find water, we find life. Even in the most extreme environments, in the crushing pressure and absolute darkness of our deepest ocean trenches, entire ecosystems thrive around hydrothermal vents. These are volcanic fissures on the seafloor, gushing superheated, mineral-rich water from the planet's interior. Creatures there do not rely on sunlight for energy. They are powered by chemosynthesis, a process that derives energy from chemical reactions. Could a similar story be unfolding in the abyssal depths of Europa? Could tidal heating create hydrothermal vents on Europa's seafloor? Could those vents support an ecosystem entirely independent of the sun, an oasis of warmth and chemistry in an ocean of frigid darkness? The thought is staggering. Life that has never known light. Life whose entire existence has played out under a roof of ice kilometers thick, unaware of the stars, unaware of Jupiter, unaware of a distant blue planet that is now dreaming of visiting. The philosophical implications are as vast as the ocean itself. Finding life on Europa would not just be a biological discovery, it would be a redefinition of our place in the universe. It would mean that life is not a miracle unique to our world, but a persistent cosmic imperative that will arise wherever the conditions are right. Future missions like NASA's Europa Clipper are being designed specifically to investigate this possibility. It will not land, but it will perform dozens of close flybys, using ice-penetrating radar to measure the thickness of the shell and confirm the depth of the ocean. It will analyze any plumes it can find, searching for the chemical fingerprints of life. Europa beckons, a pale white pearl holding the most profound secret in our solar system. But our journey does not end here. We must venture farther out to the breathtaking realm of the ringed planet Saturn. Like Jupiter, Saturn commands a diverse family of moons, each one a unique character in a cosmic play. But two of them, in particular, have completely upended our expectations. Our next destination is a tiny world, only 500 kilometers in diameter, a world so small it could fit comfortably within the borders of Spain. For most of its history, it was considered uninteresting, a small, bright, inert ball of ice. Its name is Enceladus. When NASA's Cassini probe arrived at the Saturnian system in 2004, Enceladus was a low-priority target. But science is often a story of magnificent accidents. During one of its early passes, Cassini's magnetometer detected something strange, something that suggested Enceladus was interacting with Saturn's magnetic field. This was unexpected for a supposedly dead world. Intrigued, mission controllers ordered a closer look. In 2005, Cassini flew just 175 kilometers above the south pole of the Moon. What it found was one of the greatest discoveries in the history of planetary exploration. Erupting from the surface were colossal geysers of ice and water vapor, blasting hundreds of kilometers into the vacuum of space at supersonic speeds. The images were otherworldly. A tiny moon, wreathed in a brilliant plume of its own making, was actively spraying its internal contents across the solar system. The source of these eruptions was a series of 4 parallel fissures, dubbed tiger stripes, that scored the south polar region. These were not cracks in dead ice. These were active cryovolcanic vents. Suddenly, this small, overlooked moon became one of the most exciting destinations imaginable. Enceladus, like Europa, was being heated from within by tidal forces as it orbited Saturn. This internal heat maintained a subsurface liquid water ocean. But unlike Europa's potentially sealed-off sea, the ocean of Enceladus was actively, violently announcing its presence to the cosmos. The implications were immediate and profound. Cassini was not just a remote observer. It could become a direct sampler. It could fly right through these plumes, and so it did. On subsequent passes, the spacecraft courageously plunged through the geysers, its instruments tasting the material being ejected from this alien ocean. The results were astonishing. The plumes were composed primarily of water vapor as expected, but they also contained grains of silica, tiny flecks of sand. On Earth, silica like this forms only in one environment, when hot, mineral-rich water at temperatures above 90 degrees Celsius interacts with rock. This was the smoking gun for active hydrothermal vents on the seafloor of Enceladus. The probe also detected something else: complex organic molecules, methane, propane, acetylene, formaldehyde. These are the fundamental building blocks of life as we know it. And finally, it detected molecular hydrogen, a powerful food source for microbes that live in the dark oceans of Earth. Let us pause to assemble these facts. Enceladus possesses liquid water. It has a source of energy in the form of hydrothermal vents, and it has the necessary chemical ingredients, the organic building blocks for life. All 3 pillars of life as we understand it are present on this tiny moon, and it is conveniently serving up samples of its ocean for us to analyse. It's as if we discovered a mysterious inhabited island on Earth, and a volcano on that island was helpfully erupting, launching perfectly preserved samples of its flora and fauna into the upper atmosphere for our aircraft to collect. Enceladus offers a direct pathway to searching for extraterrestrial life, a tantalizing opportunity that was unimaginable just a few decades ago. Future missions are now being designed with Enceladus as their primary target. Probes that would orbit the Moon, flying repeatedly through its plumes with instruments far more sensitive than Cassini's. Some concepts even envision a lander that would set down near the tiger stripes, collecting the fresh snow that falls back onto the surface and analysing it for the telltale chemical signatures of biological processes. The little moon that was once an afterthought has now become a prime suspect in our hunt for life beyond Earth. Yet Saturn's system holds another, even stranger world. A world so bizarre it almost seems to belong to a different solar system entirely. It is the 2nd largest moon in our celestial neighbourhood, larger than the planet Mercury. It is the only moon shrouded in a thick, dense atmosphere. Its name is Triton. For centuries, Triton was a frustrating enigma. Through our telescopes, it appeared only as a featureless, orange-hued ball. Its surface was completely obscured by a permanent, opaque smog. We knew it had an atmosphere, and a substantial one at that, composed mostly of nitrogen, just like Earth's. But what lay beneath the veil was a complete mystery. Speculation ran wild. Was there a global ocean of some exotic liquid? Was the surface a tar-like sludge? The answer came on a frigid day in January of 2005. After a 7-year journey with the Cassini orbiter, the European Space Agency's Huygens probe detached and began its descent. It was a 2.5-hour fall through the hazy orange sky, a journey into a completely unknown realm. The world watched, holding its breath. As Huygens dropped below the thickest layers of smog, its cameras began to reveal a landscape of shocking familiarity. There were coastlines, river channels, and vast, dark plains. It looked uncannily like an aerial view of Earth, but this was a deeply alien Earth. On Titan, the surface temperature hovers around minus 179 degrees Celsius. Water at this temperature is as hard as granite. The ice forms the bedrock, the mountains, the very substance of the world. The liquid that carves the rivers and fills the great lakes and seas is not water, it is liquid methane and ethane, substances we know on Earth as natural gas. Imagine a world where the water cycle is replaced by a methane cycle. Methane evaporates from vast seas like the Kraken Mare, a body of liquid larger than all of Earth's great lakes combined. It forms clouds in the nitrogen sky, and then it falls as methane rain, sometimes in torrential downpours, that carves intricate river deltas and drainage basins into the icy landscape before flowing back to the seas. It is a perfect, cryogenic mirror of our own planet's hydrological system. The Huygens probe landed with a gentle thud on a damp plain, a floodplain littered with rounded pebbles. These pebbles were not made of rock, but of water ice, eroded and smoothed by the flow of liquid methane over eons. For the first time in history, we had landed on a world in the outer solar system, and it was a world more fascinating than we had ever dared to imagine. Cassini's radar, peering through the haze over 13 years, mapped vast swaths of this strange world. It discovered towering dunes, not of sand, but of solid organic hydrocarbon particles. It found evidence of cryovolcanoes that may spew a cold lava of water and ammonia. And beneath this bizarre surface world of liquid methane, models strongly suggest that, just like on Europa and Enceladus, there is another ocean deep below, a global reservoir of liquid water. Titan is a world of dual oceans, one of hydrocarbons on its surface and one of water deep within its interior. This presents a mind-bending astrobiological question. Could life exist on Titan? If it does, it would have to be life as we do not know it. Life on the surface would have to use liquid methane as its solvent, not water. Its cell membranes could not be made of the lipids we use, which would dissolve in methane. Theorists have proposed the existence of azotosomes, cell membranes made of nitrogen compounds that would be stable in liquid methane. Such life would breathe hydrogen, not oxygen, and metabolize acetylene, creating methane as a waste product. This is the very frontier of scientific imagination. The search for this kind of weird life forces us to abandon our terrestrial biases and consider the fundamental possibilities of biology itself. Finding life on Titan would be even more profound than finding it on Europa or Enceladus. It would demonstrate that there is more than one chemical pathway to life, that the universe is not just filled with different species, but with entirely different kinds of biology. To explore this astounding possibility, NASA is preparing one of the most ambitious missions ever conceived. It is called Dragonfly. Scheduled to launch in the coming years, Dragonfly is not a rover nor an orbiter. It is a nuclear-powered, car-sized quadcopter drone. It will arrive at Titan, descend through the atmosphere, and then spend years flying from one location to another. It will fly over the organic dune fields. It will land in impact craters where fresh water ice may have been excavated from below. It will sample the material on the surface and in the air, analysing the complex organic chemistry that is taking place on this world. It will be our avatar, hopping across an alien landscape, searching for clues to a biology that may be fundamentally different from our own. Titan is a world that promises to teach us not just about the solar system, but about the very nature of life itself. Our final stop on this grand tour is the most distant and perhaps the most desolate. We travel now to the realm of Neptune, the last true planet in our system, a remote and windswept world of deep blue. It is orbited by a strange and captured moon named Triton. Triton is an outsider. Unlike every other large moon in the solar system, it orbits its planet backwards. This retrograde motion is a telltale sign that Triton was not born alongside Neptune. It is a refugee, a wanderer from the Kuiper Belt, that vast reservoir of icy bodies beyond the planets. At some point in the distant past, Triton strayed too close and was snared by Neptune's gravity in a violent and chaotic capture event. Our only close encounter with this world was a fleeting glimpse from the Voyager 2 spacecraft in 1989. The probe was at the very end of its long journey, and what it saw in the dim light of the far solar system was yet another surprise. Triton was not a dead, cratered captive. It was a geologically active world. Its surface is one of the most bizarre in the solar system. There are vast, smooth volcanic plains. There are rugged, jumbled regions that planetary scientists, at a loss for a better term, nicknamed cantaloupe terrain. And most shockingly, there were dark plumes rising from the surface, streaks of material being carried for dozens of kilometers by a whisper-thin atmosphere. Triton, one of the coldest objects in the solar system, with a surface temperature of -235 degrees Celsius, had active geysers. But these are not the water geysers of Enceladus. These are eruptions of nitrogen. The South Polar ice cap is made of frozen nitrogen. The faint sunlight, though 900 times weaker than on Earth, is enough to penetrate the translucent ice. It warms a darker layer of material underneath, in a kind of solid-state greenhouse effect. This warming causes the nitrogen ice to sublimate, turning directly into gas. Pressure builds up beneath the ice cap until it finds a weak point and erupts explosively, carrying dark, dust-like material from below and spewing it high into the sky. Triton is a world of nitrogen volcanoes. The energy that drives the larger-scale geology, the cryo-volcanic plains, is a deeper mystery. It may be residual heat left over from its violent capture by Neptune, an event that would have stretched and needed the moon for millennia. Triton is a lonely, cold, and profoundly strange place. Its future is a tragic one. Its retrograde orbit is unstable. With every pass, it is slowly spiralling inwards. In a few billion years, it will cross the Roche limit, the point at which Neptune's tidal forces will become stronger than Triton's own gravity. It will be torn apart, its fragments forming a spectacular new ring system around Neptune. The captured wanderer will be consumed by its captor. Triton is a dying world, a temporary jewel in the deep freeze of space, offering a final enigmatic lesson about the forces that shape our solar system. We have journeyed from the temperate zones of our system to its icy outer fringes. We have seen moons that hide global oceans of water, moons that erupt with plumes of ice, and moons where rivers of methane flow into hydrocarbon seas. Each discovery has forced us to tear up our old textbooks and start again. The simple idea of a habitable zone as a narrow band around a star where liquid water can exist on a planet's surface now seems hopelessly naive. We have found that nature is far more clever than we are. It has created hidden habitats in the dark, powered not by the light of a star but by the gravitational pull of a planet. It has created worlds that are more dynamic, more complex and more Earth-like in their processes than we ever thought possible. This journey changes our perspective. When we look up at the night sky, we no longer see just planets and pinpricks of light. We see a solar system teeming with possibilities. We see Europa, a hidden ocean waiting to be explored. We see Enceladus, offering up free samples of its interior. We see Titan, an alien Earth with the potential for a completely different kind of life. We see Triton, a testament to the violent and beautiful history of our celestial neighbourhood. The quest to explore these mysterious moons is more than just a scientific endeavour. It is an expression of the deepest part of the human spirit. The same curiosity that drove Galileo to point his telescope at Jupiter now drives us to build robotic explorers to fly through the plumes of Enceladus and sail drones on the methane seas of Titan. To find life elsewhere, even microbial life in one of these hidden oceans, would be the single most transformative discovery in human history. It would prove that the spark of life is not a singular miraculous accident. It would suggest that the universe is fundamentally creative, and that biology is a cosmic, not just a terrestrial phenomenon. We would finally know that we are not a lonely anomaly, but part of a grand, universal story of emergence and existence. Our journey ends here for now. But the real voyage, the one of landers and submarines and astrobiologists, is just beginning. The secrets of these moons are still locked away beneath miles of ice across an ocean of space. But we are coming. One by one, we will turn these points of light into known worlds, and in doing so, we will come to better understand the universe, and our own place within it. The greatest discoveries are still out there, waiting in the darkness, circling the giants of our solar system. Right now, as you sit perfectly still, you are hurtling through the cosmos at an almost unimaginable velocity. Our planet spins, carrying you at 1,000 miles an hour. It orbits the Sun at 67,000 miles an hour. Our entire solar system is itself a passenger, swept along in the colossal rotation of the Milky Way galaxy at a staggering 500,000 miles per hour. We are a species defined by motion, obsessed with speed. From the first foot race to the scream of a supersonic jet, we have relentlessly pushed the boundaries of how fast we can go. We build machines of fire and refined metal monuments to our desire to conquer distance, to shrink the world, to outpace the Sunday. Our fastest probes flung from Earth with explosive force slice through the void at over 100,000 miles an hour. It feels like a breathtaking pace, a pinnacle of our ingenuity. But here in the silent, sprawling arena of the cosmos, our greatest achievements in speed are rendered utterly insignificant. They are less than a crawl, a frozen moment, because the universe has a speed limit, a single, absolute and unyielding velocity that governs all things. It is a law woven into the deepest level of reality, a rule that can never ever be broken. It is the speed of light, 186,000 miles per second. Nearly 300 million meters in a single heartbeat. It is a velocity so extreme it could circle our entire world more than 7 times between one breath and the next. It is the universe's ultimate messenger, its fastest courier, the purest form of energy, the most fundamental motion there is, and nothing, absolutely nothing, can travel faster. For centuries we imagined light was instantaneous, a divine switch thrown illuminating everything at once, an infinite speed for an infinite universe. It was a comfortable, intuitive idea. But the cosmos, we would discover, is not built on intuition. It is built on a foundation of truly bizarre and elegant rules. And this rule, this cosmic speed trap, is perhaps the strangest of all. It stands as a great wall at the edge of physics. Why? Why should there be a limit at all? Why isn't speed infinite? And why this specific, seemingly arbitrary number? It is not a nice round figure. It is a precise, inscrutable value measured out to 9 digits. A fundamental constant tattooed onto the soul of our universe. A number that dictates the fate of stars and the nature of time. This isn't just a question about travel between distant worlds. This isn't merely a frustration for our science fiction dreams. This is a clue, a profound breadcrumb trail leading to the very source code of reality. The existence of this speed limit is one of the most important discoveries in the history of science, for it reveals something extraordinary about the universe we inhabit. It tells us that space and time are not what they seem. To understand this cosmic edict, we must first abandon our earthly notions of speed. Here on our world, velocities are relative. They add and subtract. If you are on a train moving at 100 miles an hour, and you throw a ball forward at 20 miles an hour for someone on the ground, that ball is traveling at 120 miles an hour. It's simple, logical, and deeply ingrained in our experience. But light plays by a different set of rules. Light breaks our logic. Imagine you are in a starship, a vessel of impossible technology, racing through the void at 99% of light speed. You are moving so fast that distant galaxies are smeared into streaks. You switch on your forward headlights. A beam of photons erupts from your ship. Now our intuition, our earthbound logic, screams that the light from your headlights must be moving faster than the light from a stationary source. It must be your speed plus the speed of light. But it isn't. If an observer could measure that beam you just fired, they would find it traveling at the exact same speed as any other beam of light in the cosmos. 186,000 miles per second, no more. Now for the deepest part of the mystery. If you inside that starship were to measure the speed of the light leaving your own headlights, you would get the very same number. It races away from you as if you were standing perfectly still. It is a horizon you can chase forever, but never ever reach, a finish line that moves with you. This is the shattering revelation that lies at the heart of modern physics. The speed of light is not relative, it is absolute. It is the one constant in a universe of ceaseless motion. It is the ultimate cosmic benchmark, the firmament against which all other motion, all of existence is measured. It doesn't matter who you are or where you are, or how fast you are moving through the cosmos. The speed of light is always the same. This single, baffling fact demolishes our classical understanding of the universe. It forces us into a new and unfamiliar landscape, a place where something else must be flexible, something must bend to preserve this one immutable law, and that something is time itself. The speed of light isn't just a limit on motion through space. It is inextricably linked to the flow of time. They are two sides of the same cosmic coin. As you approach the speed of light, as your velocity through space increases, your passage through time begins to slow down. For the pilot in that starship, moving at 99% of light speed, a clock on the wall ticks slower. Their heart beats slower. Their thoughts unfold more slowly compared to someone watching from a stationary planet. They are trading their velocity through time for velocity through space. The universe demands a balance. Your total motion through the combined fabric of space-time must always equal the speed of light. If you are at rest, all of your motion is through time. This is what we experience as the normal 1 second per second flow of our lives, the steady march of moments. But the moment you begin to move through space, you divert some of that fundamental motion away from the time dimension. The faster you go, the more you sacrifice. And should you ever reach the speed of light itself, a feat possible only for massless particles like photons, your journey through time would halt entirely. For a photon, the journey from a distant galaxy to your eye, a voyage that takes billions of years from our perspective, is instantaneous. For light, there is no past or future, there is only now. So the cosmic speed limit suddenly appears in a new light. It is not merely a barrier. It is a fundamental component of the relationship between the 3 dimensions of space and the 1 dimension of time. They are woven together into a single dynamic entity spacetime, and the speed of light is the conversion rate between them. It is the thread that stitches the fabric of reality together. It defines the geometry of the universe. But this still begs the original question now in a deeper form. Why this specific geometry? Why is the universe built in such a way that it requires this law? An infinite speed of light would imply an infinite conversion rate. It would mean that space and time were utterly separate. An event happening on the far side of the universe could be known here on Earth at the very instant it occurred. The entire cosmos would be one single shared moment of now. And in that scenario, a foundational principle of reality would completely collapse: causality, cause and effect. The most basic logic of our universe. The idea that an event can only be influenced by things that happened before it and can only influence things that will happen after it. This logical progression, this arrow of time, is what prevents the universe from descending into utter chaos. It is the principle that a glass shatters after it is dropped, not before. That a star is born before it dies. The speed of light is the ultimate enforcer of this law. It ensures that cause always precedes effect. The reason is simple yet profound. No signal, no information, no influence of any kind can travel faster than light. When a distant star explodes in a supernova, we do not see it the moment it happens. We see it only when the light from that cataclysmic event traveling at its maximum immutable speed finally crosses the vast expanse of space to reach our telescopes. If that star is 1,000 light-years away, we see the explosion 1,000 years after it occurred. For that entire millennium, the event exists outside what we call our past light cone. It is in a region of space-time that is causally disconnected from us. It could not affect us in any way because no information of its existence could have reached us yet. The universe is therefore partitioned. It is carved up into regions of influence. An event can only affect its own future, a future defined by the expanding sphere of its own light. This cosmic speed limit acts as a firewall. It prevents the paradoxes that would unravel a universe with instantaneous communication. If information could travel faster than light, you could receive a reply to a message before you had even sent it. You could learn about an effect before its cause had happened. The past, present, and future would dissolve into a meaningless soup. The universe as a logical, ordered system would cease to exist. So the speed of light is not a limitation imposed upon reality. It is the very thing that gives reality its structure, its coherence, its sanity. It is the law that allows a story to be told from beginning to end. This is a breathtaking realization. The speed limit we chafe against, the barrier that locks us within our own solar system and makes the stars seem so impossibly far, is the same law that protects the integrity of time itself. It is the bedrock of causality. It is the architecture of consequence. Without it, there would be no before and after. There would only be a chaotic, instantaneous everything. And yet we are still left with a lingering sense of mystery. We have transformed our question. It is no longer just, why this speed limit? But why is the universe built on the principle of causality? Why is it a place where events unfold in a logical sequence, where the past gives birth to the future? This seems like a philosophical question, but in the realm of physics, it might have a concrete, astonishing answer. An answer that connects the speed of light, the fastest thing there is, to a seemingly unrelated concept, the slow, inexorable decay of order. This brings us to the second great pillar of our journey, a concept as fundamental as the speed of light, but which governs not motion but possibility. It is the universal tendency of all things to move from order to disorder, from structure to randomness, from information to chaos. It is the reason a hot cup of coffee always cools down, the reason a pristine sandcastle is eventually eroded by the wind, the reason that time seems to flow in only one direction forward. It is the law of entropy. On the surface, these two ideas, the cosmic speed limit and the unstoppable march of disorder, seem to live in different worlds. One is about the hard, unchanging geometry of space-time. The other is about the messy, statistical nature of heat, energy, and information. One dictates the structure of reality. The other dictates the direction of its story. But what if they are not separate? What if they are two expressions of the same, even deeper principle? What if the reason the universe has a speed limit, the reason information cannot be instantaneous, is fundamentally tied to the way the universe processes that information? Could the speed of light be an emergent property, a consequence of the universe's relentless drive to increase its own entropy? Is the flow of causality protected by the speed of light simply a manifestation of the universe's irreversible slide towards a state of maximum disorder? This is the frontier. This is where the very nature of space-time and information converge. We stand at a precipice looking down into the source code of the cosmos, trying to understand the most basic rules of the game. The universe seems to be telling us something profound. It is saying that for a story to exist, for a past to create a future, there must be a pace to the telling, a cosmic rhythm, a maximum speed at which one moment can give birth to the next. The speed of light is that rhythm. It is the tempo of reality. It sets the clock for the unfolding of cosmic history, from the first flicker of the Big Bang to the slow fading embers of the last stars. It is both a prison confining us to our corner of the cosmos and a protector preserving the logical flow of our universe. To truly grasp why it exists, we must venture into the heart of chaos. We must explore the deep connection between the unyielding arrow of time and the immutable velocity of light. Our journey is just beginning. We must go beyond the what and finally dare to ask the deep why. How fast are you moving right now? Perhaps you feel perfectly still, a silent observer in a quiet room, but your world is in constant dizzying motion. The earth beneath you is spinning, carrying you eastward at over 1,000 kilometers an hour. This entire planet is hurtling through space in its orbit around the sun, a journey of almost 30 kilometers every single second. And our sun, with its whole family of planets in tow, is itself screaming through the Milky Way galaxy, a vast stellar pinwheel that completes a revolution once every 250 million years. Our motion is relentless, layered, and immense. And yet, amidst this cosmic ballet of incredible velocities, there is a single fundamental speed limit. A universal constant that governs every interaction, dictates the flow of time, and defines the very geometry of reality. It is the speed of light in a vacuum, a number so foundational we give it its own symbol c. It is the ultimate speed, the absolute velocity, the one cosmic law that can never ever be broken. But why? Why does the universe have a speed limit at all? Why this specific velocity and not another? The answer is not a simple decree from the cosmos. It is a story of profound discovery, of shattering old ideas, and of a journey into the deepest, most bizarre nature of space and time. A journey that begins not in the stars but on 2 hilltops in Italy, with a simple, audacious question: can we time the infinite? For most of human history, light was not considered a thing that traveled. It was a state of being an instantaneous illumination, a divine act, not a physical process with a measurable velocity. To even suggest timing, it was to suggest timing the mind of God. But in the 17th century, one man, Galileo Galilei, dared to challenge this ancient assumption. He was a mind accustomed to questioning the heavens, having already revealed the moons of Jupiter and the mountains on our own moon. Now he turned his methodical gaze to the nature of light itself. His proposed experiment was beautiful in its simplicity. He and an assistant would climb 2 separate hills at night, each armed with a shuttered lantern. Galileo would first uncover his lantern. The instant his assistant saw the flash across the valley, he was to uncover his own. Galileo would then measure the elapsed time from the moment he opened his shutter to the moment he saw the return signal. After accounting for the human delay in reaction, the remaining time, he reasoned, must be the round-trip travel time for light. Imagine the scene: the cool Tuscan air, the profound darkness of a world without electric light, 2 small flickering flames separated by a gulf of night. Galileo, his pulse, a human clock, attempts to capture a ghost. He opens the shutter, a beam slices through the darkness. Across the distance, his partner sees the gleam and responds in kind. A second beam returns. The entire event seems to happen in a single, indivisible moment. He tries again, moving the hills farther apart, straining to perceive a delay. But there is nothing, no discernible gap. The light appears to arrive at the very instant it is sent. The experiment was, by its own objective, a failure. Galileo could not clock the speed of light, but his conclusion was a masterpiece of scientific thought. He did not conclude that light's speed was infinite. Instead, he concluded that it was simply too stupendously fast for his terrestrial methods and crude timekeeping to capture. The flaw was not in his logic, but in his scale. He had brought human tools to a cosmic race, and the result was a humbling but crucial lesson. If we were to ever measure this celestial messenger, we would need a much larger laboratory. A laboratory in fact the size of the solar system. The next clue in this great cosmic detective story would not come from Earth, but from the heavens Galileo himself had so radically re-envisioned. By the latter half of the 17th century, the solar system was seen as a grand clockwork, a mechanism of exquisite regularity set in motion by a divine architect. And no part of this celestial machine seemed more reliable than the 4 largest moons of Jupiter which Galileo had discovered, especially the innermost moon, a small world we call Io. Io orbits Jupiter with a predictable metronomic grace. It disappears behind the gas giant and reappears from its shadow with a precision that astronomers in Europe began to rely on. They could use its eclipses to set their clocks to standardize time across continents, even to calculate longitude at sea. Io was the universe's most perfect timepiece, until that is, it started acting strangely. A Danish astronomer named Ole Rømer, working at the Paris Observatory, noticed a troubling anomaly in the meticulous records. The celestial clock was not keeping good time. As Earth in its own orbit moved closer to Jupiter, Io's eclipses began to happen progressively earlier than predicted. The moon seemed to be speeding up in its path. Then, as Earth swung around the Sun and began to recede from Jupiter, the trend reversed. Io's eclipses fell further and further behind schedule. The moon appeared to be slowing down. The discrepancy was significant, accumulating to a total deviation of over 20 minutes. For a universe supposed to run on perfect Newtonian laws, this was a scandal. It was as if a pendulum in a grandfather clock were to inexplicably change the rhythm of its swing. Other astronomers were baffled, proposing all manner of complex perturbations. Perhaps Jupiter's orbit was irregular, or Io's path was wobbling. But Rømer arrived at a different, far more profound conclusion. He proposed that the problem was not with the clockwork of Jupiter's moons at all. The celestial machine was perfectly fine. The problem was with the light that carried the news of that clockwork to our telescopes. He realized that the light from Io was not an instantaneous signal. It was a messenger, and like any messenger, it took time to travel. When Earth was on the near side of its orbit to Jupiter, the message, the image of Io disappearing into shadow, had a shorter journey to reach us. As our planet traveled to the far side of the Sun, that same message had to cross an additional 300 million kilometers of space, the entire diameter of Earth's orbit. The accumulated delay he was observing, Rømer declared, was nothing less than the time it took light to traverse this immense void. It was a breathtaking leap of imagination. The universe was the laboratory, and the orbits of planets were the measuring tape. For the very first time, humanity had a number. Rømer's calculation was rough by modern standards, about 25% too slow. He was limited by the imprecise knowledge of the solar system's dimensions at the time, but the principle was revolutionary. He had captured the finite nature of light. He had proven that its speed was not infinite, just incredibly, incomprehensibly vast. Light, the very essence of vision and revelation, was now a physical entity, a phenomenon that moved through space with a quantifiable, albeit staggering velocity. A new chapter in our understanding had begun. But this discovery profound, as it was opened a deeper, more troubling question. If light is a wave, and it travels through space, what exactly is it traveling through? This question would dominate the physics of the 19th century. Every wave known to science at the time required a medium. Sound waves travel through air or water. Ocean waves travel through the ocean. A wave is a disturbance in something, so it was reasoned light must also have its medium. An invisible, intangible substance that filled the entirety of space, permeating all matter, filling the void between the stars. They called it the luminiferous ether. The ether was a concept born of necessity, a placeholder for the unknown, and it had to possess some truly bizarre properties. It had to be completely transparent and frictionless, otherwise the planets would have long ago spiraled into the Sun, their orbital energy drained by cosmic drag. Yet to support the incredibly high frequency of light waves, it also had to be more rigid than steel, a ghostly paradoxical substance, both infinitely tenuous and infinitely stiff. It was the stage upon which all cosmic events played out, and if it existed, then we on our planet Earth must be moving through it. As the Earth orbits the Sun, it plows through this stationary sea of ether. Just as you feel a wind on your face when you ride a bicycle on a calm day, the Earth should experience a constant ether wind. Detecting this wind became the holy grail of physics. It would be the ultimate proof of the ether's existence, and it would allow us to measure our true motion through the cosmos. But the effect would be exquisitely subtle. Measuring it would require an experiment of almost unimaginable precision. It would require two American scientists, Albert Michelson and Edward Morley. Their device, the interferometer, was an instrument of sheer genius. It was designed to do one thing: to race two beams of light against each other. A single beam of light was split in two by a partially silvered mirror. The two beams were sent off at right angles to each other down two identical arms of the apparatus. At the end of each arm, a mirror reflected the beams straight back. The beams then returned to the center where they were recombined. If the two beams arrived back at exactly the same time, they would interfere constructively, creating a bright pattern. If one was slightly delayed, the interference pattern would shift. The logic was flawless, inspired by a simple analogy of swimmers in a river. Imagine a river with a steady current. One person swims a set distance across the current and back. Another swims the same distance upstream and then back downstream. Even though the distance is identical, the swimmer fighting the current will always take longer to complete the round trip. In the experiment, the river current was the ether wind. One light beam would travel across the wind, the other into it, and then with it. The beam fighting the ether wind should be slightly delayed. The interferometer was sensitive enough to detect even a minuscule delay, revealing the telltale shift in the interference pattern. To ensure stability, Michelson and Morley mounted their entire apparatus on a massive block of sandstone. This slab was then floated in a trough of liquid mercury, creating a nearly frictionless bearing. The entire experiment could be rotated smoothly, allowing them to point the arms in any direction relative to the supposed ether wind. The expectation was clear. As they rotated the instrument, the roles of the light beams would change. The beam that was once going upstream would now be going across, and vice versa. And as they swapped roles, the delicate interference pattern should gracefully shift back and forth. This shift would be the signature of our planet's motion through the cosmic ether. In 1887, they began their observations with breathless anticipation. They had built one of the most sensitive instruments on Earth to probe the fundamental structure of the universe. They aligned the mirrors, split the beam, and looked, and they saw nothing. Absolutely nothing. There was no shift in the interference pattern. None at all. The two beams of light against all logic were returning at exactly the same time. It was as if there were no current, no ether wind. Perhaps they thought they had just caught the Earth at a moment when its orbital motion coincidentally cancelled out the Sun's motion through the ether, a cosmic fluke. So they waited. They repeated the experiment at different times of day. They tried again in different seasons when the Earth's orbital velocity pointed in a completely different direction in space. Every time the result was the same: null, zero. A profound, deafening silence from the apparatus. The experiment designed to triumphantly confirm the existence of the ether had failed more spectacularly than any experiment in the history of science. It was a result that made no sense. Physics was thrown into a state of crisis. The foundations of our understanding of light and space were crumbling. Scientists scrambled for an explanation. Perhaps the Earth dragged a layer of ether along with it like an atmosphere. This seemed unlikely and contradicted other astronomical observations. Perhaps moving objects physically contracted in the direction of their motion through the ether, an effect that precisely cancelled out the expected delay. This idea, proposed by Fitzgerald and Lorentz, seemed a desperate ad hoc fix. It patched the wound but didn't explain the cause. The universe was presenting a clue that was also a paradox. Light simply refused to play by the rules. Its speed seemed to be the same in all directions, regardless of the motion of the source or the observer. The crisis lingered a dark cloud over the elegant world of classical physics. A new kind of thinking was needed, a mind that could not just fix the old system but tear it down and build a new one. That mind belonged to a young man working not in a prestigious university laboratory but in a patent office in Bern, Switzerland. His name was Albert Einstein, and in 1905, his miracle year, he would unleash a revolution. Where others saw a catastrophic failure in the Michelson-Morley experiment, Einstein saw a profound truth trying to reveal itself. He decided to take the bizarre result at face value. He did not try to explain it away. He accepted it as a fundamental principle of nature. What if there is no ether? What if the experiment failed to detect an ether wind because none exists? What if he dared to postulate the speed of light in a vacuum is constant, not just constant in some absolute ether-bound frame of reference, but constant for every single observer in the universe, no matter how fast they are moving or in what direction? This single, simple-sounding idea is one of the most radical and counterintuitive proposals in the history of human thought. It shatters our everyday experience of the world. Think about it. You are standing on a platform as a train rushes past at 100 kilometers per hour. Someone on that train throws a ball forward at 20 kilometers per hour. To you standing on the platform, the ball's speed is simple addition 100 plus 20. You perceive the ball moving at 120 kilometers per hour. This is the world of Isaac Newton. It is common sense. But now imagine that person on the train turns on a flashlight and points it in the direction the train is moving. The light from that flashlight blazes forward. How fast do you on the platform see that light moving? Common sense says you should add the speeds together, the speed of the train plus the speed of light. But Einstein's postulate declares this is wrong. You do not measure the speed of light as being any faster. You measure it as exactly k, and even more bizarrely, the person on the train moving alongside the beam they just created also measures its speed relative to them as exactly k, not zero, not a reduced speed, the full absolute speed of light. This is impossible. It breaks the rules of logic. Two observers moving at tremendous speed relative to one another both measure the very same beam of light and get the exact same number for its velocity. How can this be? If the speed of light refuses to change, then something else must. Something we always believed to be rigid, absolute, and universal. Einstein's breathtaking conclusion was that space and time themselves must be flexible. They must stretch and shrink, warp and bend, in order to conspire to keep the speed of light constant for everyone. This was the birth of the special theory of relativity. In this new reality, our common sense notions are revealed as illusions, byproducts of living our lives at slow terrestrial speeds. Einstein showed that for an observer in motion, time itself runs slower. A clock on a speeding rocket ship will genuinely tick more slowly than an identical clock left behind on Earth. This isn't a mechanical error or an illusion. It's a fundamental property of space-time. The faster you move through space, the slower you move through time. This effect is known as time dilation. Simultaneously, space itself contracts. That same speeding rocket ship, when measured by a stationary observer, will appear to be physically shorter in its direction of motion. Again, this is not an optical illusion. Space itself is compressed by high-velocity travel. This is length contraction. Time and space are not separate independent backgrounds. They are a single interwoven, four-dimensional continuum spacetime. And the motions of all observers carve their own unique paths through it. There is no universal now, no absolute clock ticking for the cosmos. There is only your time and my time and the time of a pilot on a distant starship. All are valid and all are relative. And within this strange, fluid new cosmos, the constancy of c creates the ultimate barrier. It becomes clear why no object with mass can ever reach the speed of light. As an object accelerates and approaches c, these relativistic effects become extreme. From an outside perspective, its clock would slow down, approaching a complete stop. Its length in the direction of motion would shrink towards zero. And most critically, its mass, its inertia, its resistance to being accelerated further would begin to increase. As you push it faster and faster, it gets heavier and heavier. Its mass grows, demanding more and more energy for each tiny increase in speed. As you approach the speed of light, its mass would approach infinity. And to accelerate an object of infinite mass would require an infinite amount of energy, an amount of energy the entire universe does not possess. The speed of light is therefore not just a speed limit, like a sign on a highway. It is a fundamental, unreachable horizon built into the fabric of space-time. It is the boundary between the world of mass and the world of pure energy, a barrier that can be approached but never crossed. Einstein, by accepting one bizarre experimental result, had not just explained it, he had overthrown 2 centuries of physics. He replaced the rigid clockwork universe of Newton with a surreal, dynamic and interconnected cosmos, a universe where the only true constant is the speed of light and everything else is a matter of perspective. This was the first great revelation on our journey to understand the cosmic speed limit, but it was only the beginning. For this new picture of space-time held even deeper secrets about the nature of gravity, the shape of the universe, and the ultimate fate of all things. There is a ghost in your clock, a subtle, unseen imperfection that haunts every measure of time, from the swing of a pendulum to the vibration of a cesium atom. It suggests that the steady, comforting rhythm of your life, the one second after another, march into the future, is an illusion, a local convenient fiction we all agree to share. The truth is far stranger, far more fluid and far more spectacular. To uncover it, we must leave behind the familiar world of our senses and journey into the mind of a young patent clerk who in 1905 shattered our conception of reality with 2 simple ideas. 2 seemingly innocent postulates that when combined unleash a cascade of consequences so profound they rewrite the very rules of existence. Albert Einstein's genius was not in complex mathematics, but in asking brutally simple questions and trusting the answers, no matter how absurd they seemed. His first postulate was an appeal to common sense. It states that the laws of physics are the same for everyone, no matter how they are moving, as long as their speed is constant. On a perfectly smooth train, you can toss a ball in the air and it will fall straight back into your hand, just as it would on solid ground. Your coffee sits calmly in its cup. From your perspective inside your moving frame of reference, every experiment you perform will yield the exact same results. There is no special privileged place in the universe. All motion is relative. So far, this feels intuitive. It is a principle of cosmic democracy. But it was his second postulate that lit the fuse. This was the true act of intellectual rebellion. Einstein declared that the speed of light in a vacuum, this very specific velocity of roughly 3,000,000 kilometers per second, is not relative, it is absolute. It is the one thing in the cosmos that never changes. Think about what that truly means. If you are standing still and shine a flashlight, you measure the light leaving you at speed x. Now imagine you are on a starship traveling at half that speed. You shine the same flashlight forward. Common sense, the intuition we've built our entire lives on, screams that the light's speed should be its own velocity plus your starship's velocity, 1.5 times. But Einstein, guided by the strange results of earlier experiments, insisted this is wrong. You, on your speeding ship, will still measure the light leaving you at sea, and, more astonishingly, a friend you left behind on a stationary platform watching you race by will also measure the light from your flashlight traveling at the very same speed, exactly not faster, not slower. The same. This one stubborn fact breaks everything we think we know about space and time. It is an impossible paradoxical observation. How can two observers moving at vastly different speeds both measure the same beam of light and get the same answer? It's like two cars driving towards each other, yet each driver sees the other car approaching at the same speed as a pedestrian standing on the sidewalk. It makes no sense. Unless the very tools we use for measurement, our rulers and our clocks, are not as reliable as we think. If the speed of light refuses to change, if it is the one inflexible constant, then something else in the universe must be flexible. Something else must bend. Something else must break. And that something is time itself. To understand how, imagine a clock of perfect simplicity, not with gears and springs, but made only of light. Picture two mirrors facing each other. A single particle of light, a photon, bounces between them. Each time the photon strikes a mirror, the clock ticks. Tick, tock, tick, tock. The distance between the mirrors is fixed and the speed of the photon is constant c. So the rhythm of this clock is flawless, dependable, absolute. Now let's put this perfect clock on a spaceship and send it flying past us. From the perspective of an astronaut on board, nothing has changed. The photon continues its simple vertical journey, up and down. Tick, tock, tick, tock. The laws of physics are the same for her as the first postulate promised. Her time flows just as it always has. But for us, watching this ship speed by, we see something entirely different. We see the clock moving horizontally across our view. For the photon to travel from the bottom mirror to the top one, it must now cover a diagonal path. The top mirror has moved forward from where it was when the photon began, and then it must travel another diagonal path to catch up with the bottom mirror. Look at the journey of that single particle of light from our viewpoint. It is no longer a short vertical line, it is a longer zigzagging triangular path. And here is the heart of the revolution. Einstein's second postulate is law. The speed of that photon is absolute. It is c for the astronaut, and it is c for us. It cannot go faster to make up for the longer distance it now has to travel. So, if the speed is fixed but the distance is undeniably longer, the only possible conclusion, the only way for the universe to resolve this paradox, is that the time it takes to cover that distance must also be longer. From our perspective, the astronaut's clock is ticking more slowly. Her tick takes longer to complete than our tick. Her time relative to ours has slowed down. This is not a mechanical error or an optical illusion. It is a fundamental property of reality, a phenomenon called time dilation. The faster you move through space, the slower you move through time. This isn't speculative fiction. It is an engineering problem we solve every day. The global positioning system, the GPS that guides your car, relies on a network of satellites orbiting Earth at high velocity. These satellites carry hyper-accurate atomic clocks. But because they are moving so quickly relative to us on the ground, their clocks run slightly slower by about 7 microseconds every day. Simultaneously, because they are in a weaker gravitational field, A consequence of Einstein's later theory of general relativity, their clocks actually speed up by about 45 microseconds. The net result is that their clocks run faster by 38 microseconds daily. If engineers did not constantly correct for this relativistic effect, this stretching and shrinking of time itself, GPS navigation would fail catastrophically. Errors would accumulate at a rate of 10 kilometers every single day. Within a week, it would guide you into an ocean. Every time you use your phone for directions, you are placing your trust in the fact that time is not absolute. Imagine taking this to its extreme. You board a vessel capable of traveling at 99.9% the speed of light bound for a star system, just 10 light years away. You say your goodbyes and embark on this incredible voyage. From your perspective on the ship, everything is normal. Your heart beats at its usual pace. Your favorite songs play at their correct tempo. You age one day for every 24 hours that pass on your ship's chronometer, but your clock is now profoundly out of sync with the universe you left behind. For every year that passes for you experiencing your journey, more than 22 years are flashing by on Earth. When you complete your round trip, which for you felt like just under a year of travel, you return to a world that is nearly half a century older. The friends who saw you off are now elders. Children born the day you left are now middle-aged. You have traveled not just through space, but through time. You have taken a shortcut to the future paid for with a currency of velocity. The rhythm of your life was slowed to a crawl relative to the world you left, all to preserve the one inflexible law, the constancy of light speed. But time is not the only dimension that must contort itself. Space, too, is a co-conspirator in this grand cosmic deception. Let's return to our intrepid astronaut on her journey. From Earth's perspective, it takes light 10 years to reach her destination. Since she is traveling just shy of that speed, her journey should take just over 10 years. And it does. From our vantage point, we watch her ship for a decade. But we just established that for her inside the ship, the journey takes less than 6 months. How is this possible? How can she cover a distance of 10 light years in only a few months? The answer is as mind-bending as the slowing of time. From her point of view, the distance itself has changed. To preserve the cosmic speed limit, the universe does not just stretch time, it shrinks space. This phenomenon, known as length contraction, dictates that, for a moving observer, the universe appears compressed in the direction of motion. As our astronaut accelerates to near light speed, the very fabric of space between her ship and the destination star squeezes together like a cosmic accordion. From her frame of reference, the 10 light-year journey is no longer 10 light-years long. It has shrunk to less than half a light-year. This isn't a trick of perspective like an object appearing smaller in the distance. For her, in her reality, the distance is physically measurably shorter. She can cross this compressed distance in a matter of months, all while never for an instant breaking the universal speed limit. The universe has conspired, bending both space and time in perfect harmony to ensure the one sacred law remains inviolate. It becomes clear that space and time are not separate, independent arenas. They are intrinsically linked, woven together into a single dynamic entity, space-time. Every object in the universe is constantly moving through this four-dimensional fabric. When you are sitting still, you are converting all your motion into progress through time. You are racing into the future at the maximum possible rate. But the moment you begin to move through space, you must divert some of that motion away from the time dimension. You trade a little of your speed through time for speed through space. The faster your spatial velocity, the more you divert, and the slower your temporal velocity becomes relative to a stationary observer. Light being pure energy with no rest, mass travels only through space. It has no choice. It moves at the maximum possible spatial speed, chi, and because all of its motion is dedicated to space, It has none left for time. For a photon, time does not pass at all. From the moment it is emitted from a distant star to the moment it strikes your retina billions of years later, from the photon's own perspective, the journey is instantaneous. It experiences its birth and its death in the very same moment. The entire history of the universe between those two events is a journey of zero duration. This inseparable union of space and time builds the stage. But there is a final critical actor in this cosmic drama, one that explains why this speed limit applies so ruthlessly to matter. That actor is mass. In his most famous equation E equals mc squared, Einstein revealed the profound equivalence of energy and mass. Mass is a fantastically concentrated form of energy, and energy under the right conditions possesses the properties of mass. When you push on an object, you are giving it kinetic energy, the energy of motion. You are adding energy to its system. But according to Einstein, that added energy must also add mass. At the slow speeds of our everyday lives, this increase in mass is infinitesimal, a rounding error so small it is completely undetectable. If you throw a baseball, its mass increases by less than a billionth of a gram. But as an object approaches the speed of light, the consequences of this equivalence become overwhelming. Imagine we are in a starship and we begin to accelerate. We fire our engines and our velocity increases steadily. For every unit of fuel we burn, we get a predictable boost in speed. We push from 10% of light speed to 20, from 20% to 30. The process feels linear, manageable. But as we climb higher, we begin to notice something strange. Our engines, which once gave us a powerful kick, now seem to be losing their effectiveness. We burn the same amount of fuel, release the same amount of energy, but the resulting increase in our speed is now smaller. We push from 90% of light speed to 91. The effort is immense. To get to 92% requires even more thrust. It feels as though we are pushing our ship through cosmic molasses, a strange, invisible resistance that grows stronger with every meter per second we gain. This resistance is the object's own mass. As we pour more and more kinetic energy into the ship to make it go faster, that very energy is being converted into additional mass. The ship is getting heavier, not because we've added cargo, but because its own motion is thickening its presence in the universe. It becomes more stubborn, more reluctant to change its state of motion. This is its inertia, and that inertia is growing exponentially. We are fighting against the very fabric of space-time itself. Now we push with everything we have. Our engines glow white-hot, consuming unimaginable quantities of energy. We are at 99.999% the speed of light. Our ship's mass, from the perspective of the universe we left behind, has swelled to hundreds of times its original value. It is now a colossal, lumbering giant. We want to close that final tiny gap, that last fraction of a percent to reach the speed of light. We try to fire the engines one last time, and here the universe presents its final absolute checkmate. As your velocity gets infinitesimally closer to c, your mass approaches infinity. The energy required for that next tiny nudge, that last push over the finish line, also balloons towards an infinite value. To accelerate any object that has even a whisper of rest mass, a single electron, a single atom, a starship to the exact speed of light, would require an infinite amount of energy. There is not enough energy in the entire observable universe to do it. It cannot be done. The speed of light is not a technological barrier we might one day overcome. It is not a record to be broken. It is a fundamental logical boundary woven into the mathematics of reality. It is the ultimate speed limit, a law not of engineering but of existence. These three consequences, the slowing of time, the shrinking of space, and the increase of mass, are not independent peculiarities. They are a unified, interwoven conspiracy of physics. a single, elegant system designed to protect one foundational principle: the absolute unchanging nature of the speed of light. It is the supreme governor of the cosmos, the ultimate regulator. This speed limit is what holds the structure of causality together. It ensures that an effect can never precede its cause. It draws a firm, unbreakable line between the past and the future. Without this limit, the universe would descend into a chaos of paradoxes, a reality where time has no direction and history has no meaning. The strange, fluid, and malleable world Einstein revealed is not just a bizarre funhouse mirror version of our own. It is our own. Its rules, forged in the fires of pure logic, are the very reason we have a universe we can begin to comprehend at all. It is a reality where the ultimate barrier is also the ultimate guarantor of order. There is a ghost in the machine of the universe, a silent, invisible current pulling everything everywhere in a single, irreversible direction. You have felt it your entire life. You feel it now in the steady beat of your own heart. It is the difference between a memory and a hope. It is the reason you cannot unscramble an egg or gather the scattered ashes of a fire back into a log. It is the reason yesterday is immutable, a fixed photograph, while tomorrow remains an unwritten page. We call this relentless one-way flow the arrow of time. But what gives this arrow its direction? What invisible archer loosed it upon the cosmos? The answer is not found in the gears of a clock or the orbit of a planet. It is found in a concept as simple as a shuffled deck of cards and as profound as the death of a star. It is called entropy. Entropy is the universe's fundamental bias for chaos. It is a law not of motion or of gravity, but of probability. The second law of thermodynamics states that in any isolated system, the overall level of disorder of entropy can only increase. It can never ever spontaneously decrease. Think of a pristine sandcastle on a beach. This is a state of low entropy, highly ordered, complex, specific. Now watch as the wind and waves reclaim it. The intricate turrets and walls dissolve into a random scattering of countless indistinguishable grains of sand. This is a state of high entropy, disordered, simple, generic. There are vastly more ways for the sand to be a disordered heap than there are for it to be a perfect castle. The universe, on a cosmic scale, is doing the exact same thing. It is simply falling towards the most probable state. And the most probable state is always one of greater mess. Every star that shines is an engine of entropy. It takes the beautifully ordered fuel of hydrogen atoms and through the elegant furnace of fusion shatters them into light and heat that radiate out into the void. This radiation spreads, cools, and dissipates. An ordered concentration of energy becomes a disordered, thinly spread wash of cosmic background warmth. The star has increased the total entropy of the universe. It has taken a single, neatly packaged thing and turned it into a vast, disorganized cloud. Every process, from the dissolving of sugar in your coffee to the explosion of a distant supernova, is a tiny contribution to this immense cosmic unraveling. The universe began in a state of impossibly low entropy, a point of near-perfect order and infinite density, and ever since the Big Bang, it has been relaxing. It has been exhaling, moving from that one special ordered state towards the trillions upon trillions of disordered possibilities. This forward march from order to chaos is the arrow of time. We remember the past because the past was more ordered. We cannot know the future because the future is a realm of higher entropy, of greater potential disorder yet to be realized. Our own minds, our consciousness, are entropy machines. Forming a memory requires energy, and in the process, we radiate heat, increasing the total chaos of the universe around us. The very act of thinking is a testament to this cosmic law. Time for us flows in the direction of increasing entropy. It is the grand unfolding story of the cosmos moving from its structured beginning to its eventual placid end. But this raises a terrifying and profound question. If the flow of time is merely a matter of statistics, a journey from a less probable state to a more probable one, is this law absolute? Could it be cheated? Could a message be sent back to the more ordered past? Could you warn yourself not to make a terrible mistake? Could a cause be undone after its effect has already rippled out? The universe says no, emphatically. And the guardian that enforces this rule, the sentinel that stands watch at the gates of yesterday, is a familiar constant. It is the speed of light. We have thought of it as a speed limit, a cosmic barrier, but its true role is infinitely more profound. The speed of light is not the speed of travel, it is the speed of consequence. It is the universe's way of ensuring one thing and one thing only, that cause will always, under all circumstances, precede effect. This principle is the bedrock of our reality. It is called causality. It is the logic that holds the cosmos together. A window shatters because a ball hit it. A star is born because a cloud of gas collapsed under gravity. Event A leads to event B. The past influences the present, which in turn shapes the future. This unbroken chain of causality is the narrative of existence. The speed of light, c, is the maximum velocity at which any cause can propagate through space-time to create an effect. It is the speed at which the universe's story can be told. When a distant star explodes, you do not see it instantly. The information of that event carried by photons travels across the light years at speed k. The effect, the light reaching your eyes, cannot arrive until sufficient time has passed for the cause to reach you. The universe does not allow instantaneous knowledge. It enforces a delay dictated by the speed of causality itself. This speed limit isn't an arbitrary rule. It isn't a cosmic traffic law designed to frustrate our ambitions. It is the very mechanism that protects the arrow of time. It is the lock on the door to the past. To understand why we must perform an experiment in our minds, an experiment that would, if carried out, tear the fabric of logic, of reason, of reality itself into shreds. Imagine a spaceship the most advanced ever conceived. It is capable of the impossible. It can accelerate past the speed of light. It is parked in orbit around Earth, preparing for a journey to a colony on a planet orbiting Proxima Centauri, 4 light-years away. Before it leaves, Mission Control on Earth will send it a message. A simple radio transmission carrying a single word, go. This message, being light, will travel at speed c-pre. Our impossible ship, however, will travel faster. Let's say it travels at twice the speed of light. From our perspective on Earth, the sequence of events is simple. At noon, we send the go message. At that exact same moment, the ship fires its engines and departs. The ship traveling at twice light speed will reach Proxima Centauri in just 2 years. The radio message plodding along at the universal speed limit will take 4 years to get there, so the ship will arrive a full 2 years before its own departure signal. This is strange, a curiosity perhaps, but not yet reality-breaking. The ship simply outran its own instructions. But now we introduce the crucial second half of the journey. The moment the ship arrives at Proxima Centauri, its mission is to immediately send a message back to Earth. A confirmation signal that simply says, arrived. This return message, like all messages, travels at the speed of light. It must now cross the 4 light-years of space back to us. This journey will take it 4 years. Now let us piece together the timeline from our viewpoint on Earth. The ship left at noon on year 0. It travelled for 2 years, arriving at Proxima Centauri in year 2. At that moment, it sent its arrived signal back to us. That signal then travelled for 4 years. So 2 plus 4 means the signal should reach us in year 6. A perfectly logical, if fast sequence of events. But we have forgotten something fundamental. We have forgotten Einstein. We have forgotten the bizarre and beautiful dance of space-time. Special relativity tells us that for the crew on that faster-than-light ship, time itself would be behaving in an extraordinary way. From their perspective, looking back at us, our clocks on Earth would appear to be running backwards. This isn't an illusion. It is a physical consequence of breaking the light barrier. So when they send their arrived signal from Proxima Centauri from their frame of reference, they are sending it into our past. Let's calculate exactly how far into our past. The math of relativity is unforgiving on this point. Given their speed and the distance, their return message will not arrive in the year 6. It will not arrive in the year 1. It will arrive on Earth 1 full year before they even left. Think about what this means. Here on Earth, in mission control, the year is -1. The go signal has not even been conceived of yet. The crew are still undergoing final preparations, and suddenly a signal crackles through the speaker. It is a message from Proxima Centauri. It is a message from their own future. It says, "Arrived." We have received an effect before its cause has happened. The chain of causality is broken. The story of the universe has been told out of order, and this is where the paradox begins to sharpen its teeth. What if the message sent back was not arrived? What if upon arriving at Proxima Centauri, the crew discovered a lethal space-borne plague that would wipe out Earth? They immediately send back a warning traveling faster than light. Warning plague, do not send the mission. This message, just like the other one, arrives a year before they leave. Mission Control receives a terrifying, inexplicable warning from a mission that hasn't departed yet. They heed the warning. They scrub the mission. The ship never leaves Earth. And if the ship never leaves, it can never reach Proxima Centauri. If it never reaches Proxima Centauri, it can never discover the plague. And if it never discovers the plague, it can never send the warning message back in time. The very message that caused the mission to be cancelled. So, if the message was never sent, what did Mission Control receive? The mission must now proceed as planned. But if it proceeds, the crew will discover the plague and send the warning, which will cause the mission to be cancelled, which means the warning is never sent, which means the mission must proceed. We are trapped, caught in a loop of impossible self-negating logic. This is not a clever riddle. It is a fundamental breakdown of reality. The universe cannot exist in a state where an event both happens and does not happen as a consequence of itself. This is the infamous grandfather paradox writ large across the stars. It is the act of soaring off the branch of a tree on which you are sitting. It is a cosmic contradiction, a sentence that erases itself as it is being written. The universe, it seems, has a profound allergy to paradox. Its foundational laws are built to prevent this kind of causal anarchy. The speed of light is not just a limit, it is a firewall. A firewall that protects the integrity of the past. It ensures that the past cannot be altered by the future, because no signal, no influence, no piece of information can ever travel fast enough to intervene in its own history. And now we arrive at the heart of the matter, the place where the two great currents of our story converge, where the arrow of time guided by entropy meets the unbreakable shield of causality guarded by light speed. Why does a universe with faster-than-light travel descend into self-contradictory chaos? Because such a universe would fundamentally violate the second law of thermodynamics. It would be a universe where entropy could spontaneously decrease. Remember our shattered glass. It falls from the table and breaks into 1,000 pieces. The system has moved from a low entropy state, a whole glass, to a high entropy state, a disordered mess of shards. The arrow of time has moved forward. The event is irreversible. But in a universe with a faster-than-light ship, it is not. You could record the glass shattering. Then you could take that recording on your ship, travel faster than light, on a carefully planned round trip, and bring the information of the broken glass back to a moment just before it was dropped. You could set up a device that, upon receiving this future information, catches the glass before it hits the floor. The effect the court glass is now preventing its own cause, the shattering which produced the information in the first place. But look at what you have truly done. You have used information from a high-entropy future to enforce a state of low entropy in the past. You have forced the universe to become more ordered. You have reversed the flow of entropy. You have, in a very real sense, reversed time itself. The second law of thermodynamics is not just a guideline about mess. It is a profound statement about the flow of information. A universe where information can flow backwards in time is a universe where the past has no integrity, where every event is provisional, subject to revision from the future. A universe without a coherent story. Imagine reading a book where the events of chapter 10 could suddenly reach back and erase the characters from chapter 3. The entire narrative would disintegrate into meaninglessness. This is what a faster-than-light cosmos would be like. A place where memory is unreliable, where consequences are temporary, where the very concept of a history would cease to exist. The speed of light, therefore, is the universe's ultimate commitment to its own story. It is the physical law that ensures the pages turn only one way. It is the mechanism that locks in the past, making it the unchangeable foundation upon which the present is built. The cosmic speed limit and the arrow of time are not two separate ideas. They are two faces of the same singular cosmic principle. The principle that reality must make sense, that the universe must be logically consistent with itself moment to moment. The speed of light preserves causality, and causality is the framework that allows entropy to increase in a coherent, linear, forward direction. This is why nothing can travel faster than light, because to do so would be to outrun consequence. It would be to gain the power to edit reality. And a reality that can be edited by its own future is no reality at all. It is an endless, shimmering paradox, a reflection in a shattered mirror. The ultimate velocity is not a barrier confining us to our corner of the cosmos. It is the bedrock of our sanity. The very law that makes a sequence of events, a life, a memory possible. It is the silent metronome of existence, ensuring that the symphony of the universe plays on from one note to the next, without ever missing a beat. The speed of light is the guardian of what was, what is, and what will be. We have arrived at a law that appears absolute, a cosmic speed limit etched into the geometry of space-time itself. It is the ultimate barrier, the final frontier of motion. But what if it isn't? What if the universe has a loophole, a secret back door? What if the declaration that nothing can travel faster than light is not a law, but merely a guideline we have yet to see broken? To understand why, reality as we know, it depends on this limit. We must do something that physics forbids. We must dare to imagine a universe without it. We must open a Pandora's box of cosmic possibility and confront the chaos that waits inside. Our journey into this impossible reality begins with a ghost, a phantom that haunts the elegant mathematics of Einstein. It is a particle conceived not in a laboratory but in the abstract wilderness of pure thought. It is called the tachyon. The name itself, from the Greek word for swift, is a challenge. According to the equations of special relativity which so perfectly describe our universe, the tachyon is a bizarre and unsettling creature. For ordinary matter, the kind that makes up you, me and the stars approaching the speed of light, requires more and more energy. An infinite amount of energy is needed to reach that final speed. This is the cosmic barrier, the insurmountable wall. But the tachyon lives its entire existence on the other side of that wall. It is born beyond the light-speed barrier. For this phantom particle, the speed of light is not a maximum. It is the absolute minimum. A tachyon can never slow down to the speed of light. To do so would require an infinite surge of energy. Its natural state is to move infinitely fast. It is a whisper that crosses the entire universe in no time at all. A fleeting thought, a mathematical spectre. Physicists have searched for them, scouring cosmic ray data, peering into the debris of high-energy particle collisions. They have found nothing, not a trace, not a single shadow. And for this we should be profoundly, deeply grateful. Because the existence of a single tachyon, just one, would not simply add a new particle to our catalogue. It would detonate the very foundation of logic. It would shatter the most fundamental principle of our existence, the unbreakable chain of cause and effect. To see how we need to construct a thought experiment, a machine for breaking time itself. Imagine two starships light years apart in the void. You are the captain of the first ship. A friend commands the second, which is moving away from you at a significant fraction of the speed of light. The universe is a stage, and you are about to perform an impossible act. You have a device, a tachyonic transmitter. It can send a message, a pulse of information carried not by light but by these hypothetical tachyons. Your message will travel faster than light. You decide to send a simple greeting to your friend. Hello. You press the button. The tachyon pulse is sent. From your perspective, everything is perfectly normal. The message leaves your ship at a moment we will call time zero. It travels across the gulf of space, arriving at your friend's ship at a later moment, perhaps time plus 5 minutes. 'Cause you sent the message, effect, your friend received it. Simple, logical, and orderly. But in Einstein's universe, perspective is everything. The strange and beautiful consequence of relativity is that time itself is not absolute. It is fluid, it stretches and it compresses. Observers moving at different speeds experience time's passage differently. For your friend hurtling away from you through space-time, the view is radically different. Because your message traveled faster than light, the bizarre mathematics of relativity perform a cruel trick. From your friend's frame of reference, the sequence of events is not just altered, it is inverted. They see your tachyon pulse arriving at their ship at a moment we can call time minus 3 minutes. They receive your greeting before you have even decided to send it. The effect has arrived before its cause. This is already deeply unsettling. It's a tear in the fabric of logic. But it is what happens next that unleashes the full paradox. Your friend, having received your hello from your future, immediately uses their own tachyon transmitter to send a reply. They send a simple message back. Don't send the first message. This reply also travels faster than light. And from your perspective back on your ship, this incoming pulse of tachyons also travels backwards in time. It arrives at your ship at time minus 1 minute. You receive a reply to a message you have not yet sent. A reply which instructs you not to send it in the first place. What do? The message from your friend, an echo from a future that might now not happen, sits on your console. Don't send the first message. If you follow the instruction, you will never send the hello. But if you never send the hello, your friend would have never received it. They would have never sent the reply telling you not to, so you would never receive the warning. Without the warning, what would stop you from sending the hello? We have created a cosmic contradiction, an event that prevents its own occurrence, a self-negating loop, a snake eating its own tail for eternity. This isn't just a clever parlor game. This is the complete and utter breakdown of causality. The principle that an effect cannot happen before its cause is not a suggestion. It is the bedrock upon which our entire understanding of the universe is built. It is the if-then logic of existence. If a star's core collapses, then a supernova will erupt. If a planet is in a star's orbit, then it will feel its gravity. If you are reading these words, it is because they were written first. But in a universe with tachyons, this fundamental grammar of reality is erased. The universe would cease to be a story with a beginning, middle, and end. It would become a chaotic jumble of disconnected sentences. A cosmic madhouse. Imagine a place where a glass could shatter on the floor, and only then leap back onto the table, reassembling itself before finally launching itself towards the edge to begin its fall. Imagine a star exploding in a brilliant supernova, its light reaching distant worlds only for the star itself to collapse inward 1,000 years later, the effect having massively preceded its own genesis. This is not a universe of wonder, it is a universe of incomprehensible, terrifying incoherence. The arrow of time, that relentless march from past to present to future, would no longer be an arrow. It would be a tangled knot. Memories would become meaningless because the past they refer to could be altered or erased by an event that hasn't happened yet. You could remember a conversation that, due to a future message, will now never take place. Is that a memory or a hallucination? The distinction would evaporate. Planning for the future would be an act of supreme futility. How can you build a house if a tachyon signal from next Tuesday could inform you that a meteor will strike the foundation tomorrow, prompting you to abandon the project, thus ensuring the meteor impact site is empty, thus meaning no warning would ever have been sent? Every decision would be haunted by the ghosts of its own consequences arriving before the choice is even made. Free will, the very idea of conscious choice, becomes a paradox. You would exist in a perpetual state of logical vertigo. This isn't merely a problem for philosophers or science fiction authors, it strikes at the heart of science itself. The entire scientific method is a testament to causality. We formulate a hypothesis, a statement about a potential cause. We design an experiment to test it. We initiate the experiment, the cause, and we observe the result, the effect. This relentless, dependable chain of events allows us to learn to build knowledge to understand the cosmos. But in a tachyon universe, this process is rendered impotent. Imagine a biologist studying a new virus. They could get the results of their experiment, the data showing a cure, before they have even mixed the chemicals in the petri dish. The cure's existence could prevent the disease from ever spreading, which would mean the funding for the research would never be approved, meaning the biologist would never be in the lab to receive the results. The universe would be actively conspiring against its own understanding. It would be a realm where knowledge is impossible because the link between an action and its outcome is severed. There would be no laws of physics to discover. How could one formulate a law of gravity? If an apple could decide to leap into the air and its gravitational potential energy could be paid back later by a tree that might or might not grow, the universe would become a cacophony of uncaused events. Things would simply happen for no reason at all. A new star might flicker into existence in the void, its birth, not the result of a collapsing nebula, but a causal eruption of matter and energy. An entire galaxy could vanish in an instant, not consumed by a black hole or torn apart by cosmic forces, but simply ceasing to be, leaving no trace, no explanation. It would be a reality governed not by order but by whim, a place of profound and ultimate uncertainty. Every moment would be a spontaneous creation disconnected from the one that came before. There would be no history, only an endless flickering, unpredictable now. This is the abyss that stares back at us when we contemplate a reality without a speed limit. It is a vision of hell, a place where logic goes to die, and it reveals the profound hidden truth about the speed of light. We are accustomed to thinking of it as a restriction, a cosmic leash that holds us back, that makes the stars so impossibly far away. We lament that we cannot break this barrier, but we have been looking at it all wrong. The speed of light is not a prison wall, it is a fortress wall. It is the guardian of causality. It is the great enforcer that ensures the universe makes sense. It is the law that guarantees that yesterday is untouchable, that our actions today will shape our tomorrow. It is the scaffolding of space-time, the structural support that allows the edifice of reality to stand. By preventing any signal, any particle, any influence from traveling faster than it does, light speed quarantines every moment from the next. It builds a one-way street for time, forcing events to unfold in a logical, sequential procession. It is the reason a story can have a beginning, a middle, and an end. It is the reason a life can be lived. The existence of this universal speed limit is what allows the universe to be a cosmos, a place of order rather than a chaos, a pandemonium of paradoxes. It is the bedrock that makes science possible. It is the foundation that makes experience meaningful. It is the silent, omnipresent rule that keeps the madness at bay. So the next time you look up at the night sky and feel the immense distances that separate us from the stars, remember the speed of light not as a limitation. Think of it as a protector. The light from those distant suns has traveled for eons to reach you, obeying that law every single nanosecond of its journey. And in that obedience, it carries a profound message. It is telling you that the universe is rational, that the past is real and the future is yet to be written. It is telling you that you are safe from the terror of a broken timeline. The speed of light is the reason we have a universe to wonder about at all. We have journeyed to the edge of space and time. We have stared into the furnace of dying stars. We have felt the chilling, inexorable pull of entropy, the universe's slow, steady march toward equilibrium and heat death. And through it all, one constant has remained a single, unyielding number, a speed limit, the velocity of light. For so long we have seen it as a barrier, a cosmic cage preventing us from reaching the stars in a lifetime, a frustrating limitation on our ambition, our curiosity, our future. But we have been asking the wrong question. We have been staring at the lock and not the magnificent door it secures. The real question is not why we can't go faster. The ultimate question is why the speed limit exists at all. The answer we are about to discover is the secret to everything. It is the reason you can remember yesterday but not tomorrow. It is the reason a glass shatters after it falls and never before. It is the reason you exist. To understand its profound importance, we must first perform an experiment in thought in the theatre of the mind. Let us imagine a universe without this law, a cosmos where information, influence, and energy can travel infinitely fast. What would such a place look like? At first, it might seem like a paradise of ultimate connection, an existence of perfect knowledge. You could know instantly what is happening on the other side of the cosmos. Every event, everywhere would be simultaneous. The light from a newborn star in a distant galaxy would reach you at the very same moment the star itself ignited. There would be no delay, no lag. The entire universe would be a single shared infinitesimal now. But look closer. Peer into the terrifying implications of this instantaneous reality. If the future can affect you as quickly as the past, what happens to the very notion of a sequence? An effect could arrive before its cause has even occurred. Think of a supernova, a star's final cataclysmic explosion. In our universe, we see the light of that explosion long after the star itself has died. Cause precedes effect. But in a cosmos without a speed limit, you could receive the light, the blast wave, the very consequence of that detonation, while the star itself was still peacefully burning in your sky. The death cry would arrive before the life had ended. The universe would be filled with ghosts of the future, haunting a present that has not yet happened. Every action you take would have instantaneous, unpredictable consequences rippling in from all of eternity. The decision to lift your hand could be influenced by the gravitational pull of a planet that will not form for 1 billion years. A paradox would infect every moment. How can you choose to act if the consequences of your choice have already happened and are affecting you now? You would be trapped in an eternal feedback loop of impossibilities, a cosmic knot of temporal contradictions. The universe would become a babble of incoherent messages, a storm of information where past, present, and future collide. It would be a place where a story cannot be told because the end is also the beginning. It would be a reality where logic itself dissolves, This is the chaos that the speed of light holds at bay. It is not a barrier, it is a guardian. It is the most fundamental law of order in the entire cosmos. The speed of light is the speed of causality. It is nature's declaration that an event can only influence its surroundings at a finite maximum velocity. Imagine an event, any event, a star igniting, a planet forming, a single thought flashing through your own mind. The influence of that event spreads outwards like a ripple in a pond. But this ripple does not travel instantly. It expands at the speed of light, forming a cone through space-time, an ever-growing bubble of consequence. Anything outside that bubble, outside that light cone, is untouchable. It cannot be affected by the event, nor can it affect it. The past is sealed off. The future remains unwritten. The speed of light is the firewall of reality. It is the mechanism that sorts the universe moment by moment. It separates what has happened from what has yet to come. It is the cosmic traffic controller, preventing the future from crashing headlong into the present. This speed limit is what carves a channel for time to flow in one direction. It is the ultimate enforcer of the sequence of things. First this, then that. First the cause, then the effect. This is the grammar of existence, the simple, inviolable syntax that makes the cosmos comprehensible. Without it, there is only the madness of paradox. With it, a story can unfold, the story of our universe. But this grand principle of causality does more than just order events. It forges an unbreakable link to that other great law of time, the relentless, inescapable march of entropy. Remember, the second law of thermodynamics tells us that in a closed system, disorder, or entropy, must always increase. A pristine deck of cards, when shuffled, becomes random. A hot star radiates its energy, its magnificent order, out into the cold, disordered void. This is the arrow of time, the one-way street from organization to decay, from structure to equilibrium. It's the reason we age, the reason stars burn out, the reason the universe itself evolves. Now we can see the breathtaking synthesis. For entropy to increase, for there to be an arrow of time, there must be a before and an after. The very concept of a progression from order to disorder relies on a strict, unbreakable sequence of moments. You cannot shuffle a deck of cards into a more random state if the past and future of the deck are all jumbled together. The increase of entropy is a process. It is a journey through a series of states, and that journey needs a path. It needs a direction. The speed of light provides that path. By enforcing causality, by ensuring that an effect must follow its cause, the speed limit builds the very timeline along which entropy can operate. It is the clockwork that allows the universe to unwind. The ultimate speed of information guarantees that the cosmic story is written one page at a time, and the pages cannot be turned back. Each moment is a transaction. Order is spent and disorder is bought. And the speed of light is the cosmic law of commerce that ensures these transactions happen in a fixed, logical progression. It is the rule that allows the universe to age. It is the engine that drives the arrow of time forward. The great unwinding of the cosmos, the journey from the Big Bang's unimaginable order to a future of cold, uniform stillness, is only possible because nothing can outrun its own consequences. The two great pillars of time's passage, causality and entropy, are not separate laws. They are two faces of the same magnificent underlying principle, a principle encoded in a single number, the speed of light. This cosmic speed limit does more than structure the universe. It structures you. It defines the most intimate and personal thing you will ever experience, your sense of the present moment, your now. Because information from the universe takes time to reach you, your perception of reality is fundamentally delayed. The light from the screen you are watching takes a few nanoseconds to arrive. The sunlight warming your face traveled for 8 minutes from the Sunday, The faint starlight you see in the night sky may have begun its journey before human beings ever walked the earth. You are never seeing the universe as it is. You are always, without exception, looking into the past. Your now is not a universal constant shared by everyone everywhere. It is a deeply personal construct, a unique slice through space-time defined by what information has had time to reach you. An observer in the Andromeda galaxy has a completely different now. Billions of years of our history are still in their future light years away, traveling toward them at the cosmic speed limit, and their present moment is a future we can never know until its light arrives. There is no absolute simultaneous present that spans the cosmos. There is only your light cone, your personal, ever-expanding bubble of the knowable past. This isn't a flaw in our perception. It is a fundamental consequence of living in a causal universe. The speed of light isolates us each within our own moving bubble of time. It ensures that the cosmos remains a place of profound mystery. We cannot know the future because the future has not happened yet, and its influence is racing toward us at a finite speed. We can only ever piece together a mosaic of the past. But this isolation is also what gives our lives meaning. It creates a space for discovery, for anticipation, for choice. The unknowable future is the realm of possibility. It is the blank page upon which we can act. If all of eternity were instantly accessible, choice would be an illusion. The speed of light protects the sanctity of the present. It bestows upon us a moment in which to exist, to think, to decide free from the crushing weight of an already determined future. It creates the space for life itself to emerge and make its way. So we arrive at the final breathtaking revelation. The speed of light is not a cosmic inconvenience. It is not a limit to be broken or a barrier to be overcome. It is the most elegant and essential feature of our reality. It is the universe's built-in mechanism for self-preservation, the foundational rule that makes existence coherent. It is the principle that prevents the fabric of space-time from tearing itself apart in a storm of paradoxes. It is the guarantor of logic, the source code for cause and effect. It is the conductor's baton that gives the arrow of time its rhythm, allowing the grand symphony of entropy to play out across the eons. This one constant velocity underpins everything we hold to be true. It is the reason we can build theories, make predictions, and conduct science. Because the universe governed by this law is reliable. It is not arbitrary. The past is fixed, a library of information we can study. The future is open, a landscape of possibilities we can influence. The speed of light is the very architecture of our understanding. It transforms the cosmos from an unknowable chaotic plenum into a grand unfolding narrative that we can, however, imperfectly read. It is the difference between a universe that can support memory consciousness and the search for knowledge, and a universe that is nothing more than nonsensical, timeless noise. Look around you, at the world, at the sky. Every photon that strikes your retina carrying information from across the room or across a million light years is obeying this law, and in doing so it is upholding the very structure of your reality. That light is not just illuminating the world for you, it is participating in the grand cosmic conspiracy that allows you to have a past to remember and a future to ponder. It allows the thoughts in your own mind to proceed in a logical sequence, one after another. A causal chain of firing neurons made possible by a universe that insists on putting cause before effect. We began this journey seeing a cage, a limit that seemed to trap us in our small corner of the cosmos. Now we see it for what it truly is, a foundation, the bedrock upon which the entire edifice of space-time is built. The speed of light is not the universe telling us you cannot. It is the universe whispering the secret of its own existence. The secret of how to build a cosmos of breathtaking scale and complexity. a cosmos of evolving galaxies, burning stars, and living worlds. A cosmos that can be. The rule is simple. To create a universe of infinite possibility, you must first impose one elegant, absolute, and beautiful limit. You must give it a speed, and that speed must be the law. Our long journey through space-time is reaching its conclusion. We have traveled from a clockwork universe of perfect certainty to a cosmos of pliable time and interwoven dimensions. We began with a simple question, a question of speed. What is the ultimate velocity? How fast can something truly move? But the answer we found was never just a number. It was a revelation that would dismantle our perception of reality itself. For centuries, we lived in a world of comforting absolutes. A universe where time was a relentless universal river, flowing at the same rate for a king on his throne and for a traveler on the most distant, undiscovered sea. Space was the fixed stage upon which this drama unfolded, an infinite, unchanging backdrop, rigid and reliable. In this Newtonian dream, speed was simple, a matter of effort. Go faster, and you could chase down anything, even a beam of light. The cosmos seemed to have no inherent speed limit at all. It was a playground of infinite possibility governed by simple rules. But deep within the mathematics that described this world, a seed of revolution was quietly taking root. It began not with a thunderous discovery, but a subtle inconsistency, a dissonant chord in the grand symphony of physics. The equations of light and magnetism whispered of something strange, something that defied all common sense and intuition. They suggested that the speed of light was not relative. It was an unyielding cosmic constant. Chase it as fast as you could, and it would still flee from you at precisely the same velocity, an impossible, maddening fact. It was a crack appearing in the flawless crystal of classical physics, a paradox that hinted at a much deeper, much stranger truth. The universe was not the straightforward machine we had imagined. It had secrets, rules hidden beneath the surface of the everyday. And then, from a patent office in Bern, came a thought experiment, a question born of pure, unbridled imagination. What would you see if you could ride alongside a wave of light? This deceptively simple query posed by a young Albert Einstein was the key that unlocked the true architecture of the cosmos. He dared to trust the paradox, to follow it to its logical end. If the speed of light is absolute for all observers, then something else must be relative. Something must give way. And that something was the very foundation of our reality, space and time themselves. Suddenly, the rigid stage of the universe began to warp and flex. The universal river of time fractured into 1 billion personal streams, each flowing at a different rate depending on motion and gravity. A clock aboard a speeding starship would tick slower than one on Earth. An astronaut on a long voyage would return younger than their twin. Time, we discovered, was not a metronome. It was a malleable fabric. Space too lost its absolute nature, contracting and expanding, becoming an active participant in the cosmic dance. The unyielding separation between here and there now and then dissolved. They were merged into a single unified entity, space-time. And within this new four-dimensional reality, light speed was law. It was revealed not as a simple velocity through space, but as a fundamental property of the fabric of space-time itself. It is the speed at which reality propagates, the rate at which ripples, disturbances, and information can travel across the cosmic ocean. This is the legacy of our scientific journey, a breathtaking ascent from a flat, predictable world to a dynamic, relativistic universe. But understanding the what and the how is only the beginning. The truly profound question, the one that touches on our very existence, is why? Why must this speed limit exist at all? What purpose does this ultimate cosmic statute of limitations serve? The answer takes us beyond physics and into the realm of causality, into the very logic that makes the universe a comprehensible story. Imagine for a moment a universe without this law, a cosmos where the barrier of light speed could be broken. What kind of reality would that be? At first, it sounds like a dream of liberation, of ultimate freedom. Galaxies once separated by impassable gulfs of time and space would become neighboring shores reachable in an instant. We could traverse the entire known universe in a single lifetime. We could witness the birth of stars in Orion and the death of suns in Andromeda, not as ancient light, but as current events. The vast, lonely distances of the cosmos would shrink into nothingness. But this dream of instantaneous travel hides a terrifying nightmare. It is a dream that would not liberate our universe but shatter it. In a reality without a speed limit, you could outrun consequence. An effect could arrive before its cause was ever put into motion. Think of what that would mean. You could receive a message from a distant starbase, a message sent tomorrow arriving today. You could watch a supernova explode in the sky, then travel faster than its light to arrive at the star days before it ever began to collapse, watching it shine peacefully. The unchangeable past would become a shifting, editable draft. You could travel back along your own timeline and prevent the event that caused you to make the journey at all. A paradox, a loop of impossible logic that tears itself apart. This is not a universe. It is an incoherence. The cosmos would become a maddening chaos of self-contradiction. Every event would be both true and untrue, a phantom reality where history has no meaning because it can be endlessly unwritten. The arrow of a hunter could land in its target before the bow was drawn. A civilization could be annihilated by an asteroid impact that they had already traveled to deflect a century earlier. There would be no stable chain of events, no reliable history, no foundation of fact upon which to build a future. There would be only an endless churning fog of possibilities, a realm of cosmic ghosts where every moment is a potential lie. This is the pandemonium that the speed of light holds at bay. It is not a barrier. It is a guardian. It is the universe's most fundamental law of order. C-Plane is the ultimate speed of causality, the rate at which one event can influence another across the expanse of space-time. It ensures that the past is prologue that causes precede effects, that the story of the universe unfolds in a logical, coherent sequence. It transforms the cosmos from a storm of meaningless data into a grand unfolding narrative, a story with a beginning, a middle, and an end. It is the principle that allows you to trust the ground beneath your feet, to know that the sun that warmed you yesterday is the same sun today. It is the law that separates memory from fantasy. Without it, there is no science, no history, no you. Our very consciousness, our ability to perceive a linear flow of time, is a direct consequence of this cosmic speed limit. It is the law that makes existence understandable. But its role as the protector of logic is only one part of its deep purpose. This constant of nature is woven into an even more profound cosmic tapestry, one that dictates the very direction of time's arrow itself. It is inextricably linked to one of the most powerful and mysterious forces in the entire universe, the relentless, irreversible march of entropy. This is the second great law of thermodynamics, the principle that states that over time, in any isolated system, order inevitably dissolves into disorder. It is a law written into the very fabric of existence. It is why a hot cup of coffee always cools down its organized heat, dissipating into the disorganized chaos of the surrounding air. It is why a dropped glass shatters into 1,000 pieces, but those pieces will never spontaneously leap back together. It is why stars burn through their fuel, collapsing into remnants, and not the other way around. Entropy is the universe's great, irreversible breath. It is the force that provides a clear and unambiguous direction to time. The past is a state of lower entropy, of greater order, like an unbroken egg. The future is a state of higher entropy, of greater disorder, a scrambled mess. You can always turn an egg into an omelette, but you can never turn an omelette back into an egg. This one-way journey from order to chaos is what we perceive as time. It is the fundamental difference between yesterday and tomorrow. But what does this have to do with the speed of light? The connection is one of the most elegant and startling in all of science. It reveals not just as a guardian of logic, but as the enforcer of time's flow. Consider again the nature of light itself. For a photon, a particle of light traveling at the cosmic speed limit, a strange and wonderful thing happens to time. From its own perspective, time ceases to exist. It stops completely. For a photon born in the core of a star a million light-years away, its journey across that immense void to your eye is instantaneous. The moment of its creation and the moment of its arrival are one and the same. It experiences no duration, no passage of moments, no ticking clock. It does not age. It does not decay. It exists in an eternal timeless now. At the speed of light, there is no before and no after. There is no past to remember and no future to anticipate. And in a place where there is no passage of time, entropy has no meaning. A process that requires time cannot unfold. Change itself is impossible. Now think of us, beings of mass, of substance. You, your planet, your galaxy are all fundamentally incapable of ever reaching this ultimate speed. The laws of relativity dictate that as you approach light speed, your mass increases infinitely, requiring infinite energy to go any faster. This cosmic prohibition, this inability to reach the timeless realm of light, is precisely what chains us to the relentless current of time. Our separation from that ultimate velocity is what creates our temporal reality. Because we move slower than light, we are forced to experience duration. We are compelled to witness one moment giving way to the next. And by being locked within this flow, we become subject to its laws. We are forced to witness the unfolding of entropy. Our existence below the speed of light is what allows the universe to have a history to evolve to change. It is the reason stars can be born from clouds of gas and dust, live for billions of years, and then die in spectacular explosions. It is the reason planets can form continents, can drift, and life itself can emerge from simple chemistry, growing more complex and ordered over immense eons. All of this, the entire sweeping epic of cosmic evolution, is only possible because we live in a universe with a temporal dimension, a universe where before can lead to after. The speed of light acts as a great wall, a demarcation line. On one side, the timeless, changeless existence of light. On the other, our world, a realm of change, consequence, and becoming. The speed limit is the very mechanism that enforces the arrow of time, ensuring that the cosmic story moves ever forward from simplicity to complexity, from the ordered fire of the Big Bang to the diffuse coolness of the far future. It is the engine of cosmic history. So we stand at the end of our exploration looking back at this profound, universal law, and we see it in a new light. The speed limit of the universe is not a cage that confines us. It is not a frustrating barrier to our interstellar ambitions. It is the essential architectural principle of our reality. It is the scaffolding that makes a coherent universe possible. It is the law that imbues our existence with meaning, with story, with the very concepts of past, present, and future. Far from being a limitation, it is the greatest of gifts. It is the rule that allows other rules to exist. Even the immense, seemingly empty distances it enforces between the stars are part of this elegant design. Because light travels at a finite speed, the sky above us is transformed into the most magnificent time machine we could ever build. When you gaze upon the Andromeda galaxy 2.5 million light-years away, you are not seeing it as it is today. You are seeing it as it was 2.5 million years ago. You are looking into the deep past. The light from that distant island of stars began its journey long before modern humans walked the earth. Every star in the night sky is a portal to a different epoch. The farther we look, the deeper back in time we see, all the way to the faint residual glow of the Big Bang itself. The speed limit preserves the cosmic history book, allowing us to read its pages simply by looking up. The universe's past is not lost. It is perpetually arriving at our doorstep. This cosmic constraint has also been the primary catalyst for our ingenuity. It has forced us to become more than just travelers. It has compelled us to become listeners, observers, and thinkers. Unable to simply go to the stars, we learned to understand them from afar. We built colossal telescopes, instruments of astonishing precision, to capture their ancient light and decode its secrets. We learned the language of spectra reading, the chemical composition of suns trillions of miles away. We built detectors to feel the faint tremors in space-time itself, the gravitational waves from colliding black holes a billion years in the past. The limitation has fueled our greatest scientific triumphs. It has pushed us to develop a deeper, more subtle, more profound connection to the cosmos than mere physical presence could ever offer. It challenges us to be clever, to be patient, to be brilliant. The speed of light does not stop us from exploring the universe. It defines the very terms of our epic quest. And so, we are left here on our small world, staring out into the incomprehensible darkness, armed with this extraordinary understanding. We are creatures of matter and time, forever bound to move slower than the light we use to see. We exist as part of a grand unfolding story, a narrative made possible by the very laws that constrain us. We are the universe's way of knowing itself, a fleeting consciousness that has arisen within this framework of elegant, unbending rules. Our journey to understand the speed of light is a mirror of our own evolution, a passage from simple intuition to a humbling, complex truth. The questions, of course, do not end here. They multiply. Is this speed limit truly absolute? Does it hold true inside the crushing singularity of a black hole, where our known laws of physics crumble into meaningless equations? Was it the same in the first searing fractions of a second after the Big Bang, or has it too evolved with the cosmos it governs? Are there hidden dimensions, other realities where information might find other pathways, other rules to follow? These are the questions that will fuel the next generation of explorers, of dreamers, of scientists who dare to ask, what if? They will continue to push at the boundaries of knowledge, inspired by the magnificent, intricate design that surrounds us. The speed of light is so much more than the answer to a question. It is the rhythm of the cosmic heartbeat. It is the guarantor of logic, the enforcer of history, the thread that weaves space and time together. It is the silent, ever-present principle that allows a universe of beautiful, breathtaking complexity to emerge from chaos. It is a testament to the idea that our cosmos is not a random accident, but a place of profound and deeply interconnected laws. To live in such a universe, to be able to perceive it, and to even begin to comprehend its foundational rules, is the most astonishing privilege of all. The cosmic speed limit does not tell us where we cannot go. It tells us why we are here, undefined.